Welcome everyone and good morning. It's awesome to have you all here. The fact that you're here in this late Friday and that you're all here means that you're actually interested in building highly scalable big data analytical solutions and over big data and time series. So that's great to have you here. And it's a pleasure. It was a pleasure. All the week was actually super exciting meeting a lot of you and spending the time talking about these interesting things. I'm Uri Barash, and I'm the Group Program Manager for Azure Data Explorer. We'll see today two super exciting projects that demonstrate real-time interactive analytics over massive amounts of data, and we'll also see some of the new capabilities and features that makes this possible. So when we're talking about cloud scale analytics we are talking about like three main customer patterns that we are identifying. The first one is the modern data warehouse. And this week we actually announced Synapse as the new version, as the rebranding of the modern data warehouse, the SQL data warehouse, including with the ETL engine in Spark, Data Factory, and the integration with machine learning, all that in an integrated product. This is the realization of the modern data warehouse pattern that we've seen over and over and over again, and this is a very important element in how enterprises are operating. To its right, we see the real-time analytics pattern. And this is a very fast-growing segment because the data that we're seeing coming in, we need it to be in real time. We'll talk about the need for real-time analytics in a second, but this is where we are focusing our session today. And the last one is the advanced analytics. Once those things are there, we need to be able to empower machine learning and AI and make sure that we leverage this data in new and innovative ways. Manoj Raya from our team actually did a wonderful theater session earlier this week on Thursday. And this is available online to see as well. So when we're talking about real-time analytics, what's going on? The new generations of workers actually expect more from computer systems. They expect data to be fresh. They expect all the data to be available for them. And the agility of the business environment requires them to be up to date and available to access these things. We're seeing more and more data stream coming in from devices, from customers, interaction with customers, interaction with employees, interaction with vendors, with business partners, even with the weather, with the marketplace we operate in. All these data streams are coming in, and every organization needs to make sense out of those in many cases in real time and in ways that we didn't predict earlier. That agility of the business environment also requires that we have more data-driven people and data-empowered people that can actually make those decisions. Look at the data, analyze the data, understand the reality, and make decisions that will drive the organization forward. This is practice, is the essence of the digital transformation. This is the essence of what it means. Now we're talking about data coming in from a lot of different direction into hubs, event hubs, IoT hubs, but there are many other technologies that serve there, or even through Blob. These diagrams are actually not representing necessarily our products, but how organizations are actually doing these things. Some of those can be open source. Some of these can be custom built by an organization, but those flows are actually pretty consistent, and you'll see two examples of those in real-life scenarios today. And the information that's coming in, it's coming, flowing via those hubs and via Blob Store, and they are handled in two main ways. One, as a stream analytics, standing queries in memory that can respond in milliseconds to things, respond and fix the reality, trigger alerts, and do other things. Based on that, update like really fresh dashboards. And going into Azure Data Explorer to enable analytics of the data that just arrived in the context of the data from the last days, weeks, and even months, even years. And once the data is available, you can actually analyze it. You can use it for creating real-time application, real-time dashboards, alerts, investigation user experiences, and then like export them to the data lake, do other things with them. So Azure Data Explorer, how many of you have heard about the product before this week? Okay, that's a fair amount, like about half. So it's not surprising because we just announced the product a year ago here, and we just launched it as a generally available service on February. And that type of information takes time to propagate. And that's okay. And it's great that you're here because you can see the practical magic that we're doing with this product. It's a product that has been in production at Microsoft for 6 years now, and it's one of the main data platforms at Microsoft that is driving interactive analytics. So what is it? It's a fast and scalable interactive analytics service that cuts down time to insight, can ingest huge amounts of data per second. It can ingest almost 12 megabytes of data per core per second. And because we can scale out horizontally practically as much as we need, we have clusters that are ingesting data in a rate of like 300 terabytes per day. It's a fully managed service, and it provides auto-scaling capability, management-free indexes, and allows you to focus on the things that you want to do, like your application, your solution, rather than maintaining and lubricating the servers that are doing the work. And the last and interesting thing here, sorry about that. The last thing is that it uses a query language called Cousteau Query Language, has been exposed by other products like Azure Monitor, Application Insight, Log Analytics. It's getting a lot of traction. It's now getting traction also in other places. I'll talk about it in a second. But the real essence is that at Microsoft, this really drove the digital transformation, because today we have over like 30,000 employees at Microsoft that are running queries on questions that they didn't know about yesterday against Azure Data Explorer. And that's about a fourth of the workforce. Think about it. A fourth of the workforce is reaching out directly into the databases and getting answers to questions that they need. This was not the case 6 years ago, and we have completely changed the culture of the engineering teams. And today, you can't set up an Azure data center, for example, if Azure Data Explorer is not there. It's like Azure Storage, Azure Compute, and Azure Data Explorer in order to start operating a data center. So how people are using the product? Some companies have decided to go and create a framework for how they sense information coming from everywhere. And Microsoft has done it internally, but Tabula, DocuSign, and you'll see Grab and Bosch doing the same on building a framework where all the relevant telemetry can flow into a single platform, and people can go and get answers to their questions with all the data that's relevant. Another interesting pattern is where companies are actually purchasing a solution in a specific vertical, finance, gas and oil, and others, in order to address this. And all the Microsoft built solutions as a service are actually running this way, running on Azure Data Explorer. And we are now seeing quite a lot of partners and customers of us that are building vertical-specific analytical solutions on top of Azure Data Explorer and are providing the same value and same service to companies that empowers employees to reach out into data in the specific domain and leverage it. And the last one is companies like BASF that are using Azure Data Explorer to optimize chemical processes across many plants, across many areas, in order to optimize how the entire thing is working, reduce waste, and increase efficiency, and using a lot of machine learning and machine optimization in order to drive this capability. Yes, and as I mentioned, all the analytical solutions and service that we ship from Microsoft in the data center operations, in security analytics, in IoT analytics, in game analytics, and more are coming, are built on Azure Data Explorer, including Azure Billing and all the internal platforms that we're using. So, I'll tell you a story. A person that is driving over the highway and his wife calls him and tells him, be careful. There is some guy driving against the direction on the highway. So only one, there are many of them. So I would like to invite Bernard and Dang from Bosch to tell the story on how they are addressing that story. Welcome.
Thank you.
Thanks.
So, thank you. We are very proud to be here on the stage with Uri. My name is Dang. This is Bernhard from Bosch. We are both software developers. Let me briefly introduce you to our company. Maybe you don't know much about Bosch. Bosch is a global company with subsidiaries in over 60 countries. We have over 400,000 associates, and we operate in industries, in many different industries. We produce power tools, consumer goods. There are many technologies of us you can find in industrial technologies, and most importantly, we are heavily involved in the automotive industry as one of the largest car supplier. And within this big company, we both belong to the business unit called the Connected Mobility Solution Business Unit. There we developed connected services to help the drive much more safer in your car. And one of these features is the wrong way detection system, which we have built. And we began with this service with a research on statistical facts, which I want to show you a little bit. You can see that the wrong way driving event is quite a rare event, but it has drastic implications. And surprisingly, half of the wrong way driving events begin on highway entrances. And most of the accidents occur already within the 500 meters. This means that in order to help saving lives, we have to create a solution which works very quick in real time. And for that, we use Azure Data Explorer, which is a really important part in our solution. Let me explain to you how our solution works in detail. Essentially, the cars which integrates our functionality sends us GPS data. And those GPS data are analyzed by our backend via map matching algorithms. So we take GPS data and map match them to road elements, and based on that, we can conclude that whether it's a wrong-way driver, yes or not. And in the case of the detection, we would inform the driver or the driver, and we would also inform and notify the affected traffic. And also we can cooperate with road authorities and radio stations so that they can inform their audiences too. So basically, we have built up a backend service which is based on a streaming architecture. On the top part, you can see the so-called hot path from us, where the data is really being processed in real time. On the lower part, you can see our data analytics pipeline, where we use Azure Data Explorer to get all the telemetry out of our system in order to optimize our algorithm with it, and in order to apply machine learning concepts on it. But the wrong-way driver detection system is not everything what we do. Actually, we have more services which we currently build, and we use it as a place to aggregate all the data which we get. And Bernhard, my colleague, will show you now the services.
Okay, thank you. Hello. I will just switch over. So as Dank just told you, we're working on many services at Bosch, connecting cars, making the mobility better and safer. And we've brought to you 4 different services, and I will just go over it and explain what you can see on this little map. The whole map is being, the data behind it is coming from Azure Data Explorer, so we're basically different teams throwing everything into Azure Data Explorer and visualizing it here for you. The first thing is the road condition service. It's like how good are the conditions on the streets across our supported areas. What you can see is that most of parts in Europe are quite good, and in southern Germany you see those yellow lines, which means it's kind of slippery at the moment, so it seems to be raining at our hometown. The second service is the wrong-way driver warning service. That's the purple point showing across all the highways. That's basically people going on or off a highway over the last 15 minutes. Then what we also got is the convenience charging, which is we're basically building a service to manage electric charging stations and manage the stations at all. And every time one of those green bubbles pops up, somebody is connecting or disconnecting his electric vehicle somewhere in Europe. And this is just the stations that have been changing over the last couple of minutes. I think with more than 20,000 stations across in Europe, we could zoom in and show everything, but I won't go into detail. And the last thing is a quite interesting service, which is called community-based parking. There they take car sensors, you know, the beep-beep sensors, and when you're going across the street, the car will automatically detect if there are free parking lots and send it to our database. And if you ask your car, hey, I need to park there, the car can tell you, okay, this area, there should be some places free to park. Yeah. Regarding time, I will just hand back to Uri. Thank you very much. Enjoy the rest of the day.
Awesome. Thank you very much, Dank and Bernhard. This is a wonderful project, very innovative and very powerful. So really nice to see this. Super important. So, yeah, so a lot of those real-time analytics are actually working today already in on-premise settings or on clouds, running on VMs with a pretty wide range of technologies. And there is a lot of movement from on-premise and those VM-powered solutions to PaaS services, to managed services. And that migration is what we are working to empower, reduce the friction, and make it easier to do. The next example is an example of such migration where we're taking a massive workload and are moving it to fully managed services on Azure. And I would like to invite beyond that, after we see this example, we can also see the features that are making this possible. So I'd like to invite Ainu Najib from Grab in Southeast Asia. So welcome.
Okay. Thank you, Uri. Good morning, everyone. It's really great to be here. How many of you knows Grab before you come here? All right, thank you. That's more hands before than my session before. So put it simply, Grab is Uber of Southeast Asia. And in fact, Uber's operation in Southeast Asia 1.5 years ago were merged with us. So now Grab conquering Southeast Asia and Uber is the rest of the world. But we are more than just ride-hailing and food delivery like Uber and Uber Eats, which I'll come there later. My name is Ainu Najib. I'm head of analytics, platform, and regional business. And Grab is recently ranked number 4 in CNBC's Disruptor 50. We are also ranked second most innovative company in the world, second after Meituan Dianping in China. In terms of ride-hailing, we are number 4 in the world. Now, this is a quick sneak peek on who we are and what kind of impact we make in Southeast Asia. Would you like to guess how many populations are there in Southeast Asia? There are 11 countries there. No? No takers? There are 660 million people in Southeast Asia. And 1 out of the 6 of them uses us. And you see, we empower driver partners as well as for our partners for other use cases that we provide. And we empower over 9 million people. And just driver itself is, every day there are more than 1 million drivers on the road throughout these 8 countries in Southeast Asia where we operate in more than 100 cities. And beyond just ride-hailing, we operate in 339 cities in total. So that is the scale that we are talking about. And not just scale, there are so many variety of services and use cases that we provide on the platform, as you can see here. And even within a vertical, there is more customization in there. There are different offerings that we give to our customers to serve their need. Now, why do we need real-time analytics? It goes without saying that ride-hailing is a real-time industry. Food delivery is a real-time industry. I bet if you come here using Uber, you will be so impatient if it doesn't come in on time, right? You'd rather have the driver waiting than you waiting, right? And if you order food, you're so hungry, you definitely cannot wait any more minutes of hunger. You really want it to be delivered timely, which means for us, in over 100 cities where we operate in, the operations team need real-time visibility of the market, need real-time visibility of the supply, of the demand, and how the matching between supply and demand happens. Because we cannot teleport people, right? The matching and the analysis has to be by area, by city, by specific locations. And not just this, we also need to analyze or monitor wide ranges of metrics to measure our performance. Take one example, EFTA is one of our holy metrics. It's one proxy metrics with such a complex logic that is representative of both supply and demand and the matching, as well as how effective our system overall in allocating them. Then you have acceptance rate, book-through rate. They all can change depending on the dynamic of the markets and also the number of services that we are rolling on. So it's crucial to have agility to be able to implement this fast without requesting to IT and then get the monitoring implemented in few weeks or few months. Now, here is the architecture that we have. As you can see, the telemetry coming from the user apps and the driver partners apps, as well as our merchant partners app, in real-time streams all the way into Azure Event Hub Then we partition further using stream analytics jobs just to split between countries and also between different verticals or services. And then we dump all those data into Azure Data Explorer, as well as into stream analytics for more real-time on-the-fly processing. So from Azure Data Explorer, we connect to Power BI for monitoring. Right? Now, why do we find ADX, Azure Data Explorer, to be such a compelling solution to solve our problems? It boils down really to just three things, in essence: scalability, reliability, and agility. It goes without saying we need scalability. We process over 1 trillion events every day. And that's not joking. I actually checked first before I present this, that there are indeed more than 1 trillion events every day that we process. Then we also need reliability. We do not want this monitoring to go down. We don't want our teams, operations team on the ground to have blind visibility. And agility, I cannot emphasize this more because of the dynamic of the product and services they offer, dynamic of the markets. We need to be able to respond fast, monitor fast. Now, could you guess how long did it take for our analytics team, for our country analytics team, to go from 0 to hero? From knowing nothing about Azure, knowing nothing about Azure Data Explorer, to finally able to implement end-to-end production-ready monitoring solution. Any takers? How long do you think? A month? 3 months? 1.5 days. 1.5 days, and I'm not joking. So the moment we in the central team in Singapore managed to build POC end-to-end, we got Microsoft to help us conduct a hackathon. We flew in our country analytics team from Indonesia, Malaysia, Thailand, Vietnam, Philippines. We flew in from 8 countries where we operate in Southeast Asia. And we get them to do hackathon for 2 days, half day for briefing and all. And every single team was able to implement end-to-end solution, which we were so impressed ourselves. Now, that's agility. But yeah, enough talking. I'll be sharing demo about how interactive it is and how fast it is for our analysts to perform analysis. Okay, so just to give you a taste what it looks like, these are example of our drivers on the move. And every few seconds, the phone app will ping their GPS location and many statuses into our real-time stream just now that you saw. And these are those same driver partners who are idling and staying in one place waiting for, this is near a train station. Now, imagine that at scale, like more than 1 million of them every day across 8 countries. So I'll show you this cluster. So here you see there are 7.5 billion data points of GPS pings from these drivers in this particular ADX cluster. So let's take the last 1 day. In the last 1 day, there are almost 100 million pings, right, that we store. And as you can see, the query was super blazing fast. Now, let's say the analyst wants to analyze, in the last 1 day, how did their estimated time to trip in P75 and P95 was performing. So here, voila, in just less than 5 seconds, okay, I got my chart. And then let's say I want to compare that, the last 1 hour performance with the same hour last week. So I run this pretty much more complex query. And yeah, in no time, I get the results. And this is on top of 7.5 billion data points, yeah. So, okay, I want to see, right, I just want to compare, right, that there seems to be difference here significantly, but the rest are okay, right? And not just that, you can implement anomaly detection as well. So you can use series decomposed anomalies function available in ADX. And yep, you get it. So we can see here, if you see here, there are a couple of anomalies, right? And let's say, oh my God, I forgot, I need to just analyze for one series. Okay, let me just filter by this particular series number 10. And you see, in just a few seconds, I got the answer. Oh, and apparently there is an interesting anomaly situation happening here. So imagine this level of agility. Your analyst can just change the question anytime, and it's blazing fast to get the answer quickly. So that is the benefit that we have realized from Azure Data Explorer. Thank you, Uri.
Ainun, thank you so much. This was really an amazing project, and he's not exaggerating. This was a blazing fast also development, not only service. So in order to make those kind of like migrations from, in many cases, Elastic or Splunk on-premise to the cloud, we've enabled a few capabilities, and the ecosystem with open source is helping us a lot. For example, in the Grafana area, we've added the support for alerts. So now if you're using Grafana with your Azure Data Explorer, you can enable automation of alerting with Grafana alerts. Grafana is an open source software. Our friends at Dodo Pizza, who adopted in a very similar pattern Azure Data Explorer in a couple of days, have created the connector for Redash.io. Redash.io is a very popular open source big data dashboard application. And they've created that connector, published it, etc., and now it's available for use. It's a very cool dashboard application. And the last one, I actually want to show you this, because when you do migrate these kind of things, you can see that we have here a list of the conference session here, and you're seeing the ADX UI showing the list of the conference in Ignite. And this is a Kibana running against exactly the same data set. So now you're seeing all the conferences in the last year. But if we're searching for Ignite, then you see the two Ignites for last year and this year. And this is work of the commercial software engineering team at Microsoft that has picked up this project, created an open source project for bridging Kibana and Azure Data Explorer. And we're going to make this a public GitHub repo very, very soon, so we can have like more contribution and continue to evolve it to support all the functionalities. Yes, this is the Kibana. We have the Logstash and the Kafka connectors in open source, public open source for a long time now, and they are very commonly used. They have been used also by the Grab and Bosch examples that you've seen earlier. And Fivetran, which is a software company that does data movement services, have also included a connector to Azure Data Explorer. So now you can also use Fivetran to move data in and out of Azure Data Explorer. If we're talking about ingesting data, I'm very happy to announce that we've completed the support for Azure Data Lake Storage Gen 2. So now you can use Azure Data Lake Storage Gen 2, both for ingestion of data, queued ingestion and listening on the data lake, but also for exporting data into Azure Data Lake Storage and to query data native in the lake. It's slower than using Azure Data Explorer for the data inside the service, but it's still very useful to connect data in the lake and data that's managed inside the service. And one of the very popular formats for data in the data lake is Parquet. And next week, we are going to release the high performance Parquet, so the queries against data in native Parquet in the lake will be dramatically faster. The last thing here is actually a piece of magic on how we are taking data either as a file on a local computer or as a file in the data lake, and we ingest it into Azure Data Explorer in one-click ingestion. We're generating the table, guessing the schema, creating the schema, creating all the mapping, even if it's JSON or a Parquet, creating the mapping automatically. Even for files that have like 700 columns, we just generate the table, generate the schema, and it makes it very easy to run POC and start using the service. This is a very exciting announcement that we've made with the Azure Data Share team, beginning of the week. And it empowers us to do the following thing. We're taking a database in Azure Data Explorer and we're sharing it to another instance of compute of Azure Data Explorer, both looking at the same source data in the middle, the same live data, without copying, but still making it possible to use different computes for the same workload. What does it give us? It gives us the ability to share databases between teams. So each team pays for their own bill. Each team is not impacting the performance or the SLA of the other workload. And that is a very popular deployment internally at Microsoft, and we're seeing it more and more in other companies. Bueller has done that for one operational cluster that does the dashboarding and the real-time application, and one cluster that is making the information available for the data science team that can party all day long on their own dedicated compute. But it actually goes farther than that. You can share it with your partner. If you have another company that you work together on the same data, again, you can have like both companies look at the same data across tenants, across companies, and that data sharing is very useful in order to do this. The most interesting aspect here is actually the ability for companies that are building multi-tenant SaaS solutions to share the data that's accumulated for a specific customer with that customer. So we actually blur the lines between the ISV data and the customer data. So even if I'm giving services to a customer on something that's happening in their own domain, they can still use the same data in order to correlate with other data that they have in their own subscription, in their own operation, without requiring me as a provider of an analytical solution as a service to provide them API access that I need to operate and maintain SLA for. I'd like to invite Manoj to do a demo of how this works.
Thanks, Uri. Okay, so as Uri mentioned, you can share your databases easily with your internal partners as well as external partner, and the receiving party could be in the same tenant as well as multi-tenant. Like let's say Microsoft wants to share data with Bosch, for example. Bosch is other tenant. They would have Bosch.com in AAD tenant, so they could have their data, their cluster in their tenant, and we can just share the database with them. Let's say this is our cluster, a demo cluster, which has a bunch of databases. So I want to share an occupancy database with someone else. So all that I have to do is I have to provision a data share service. Again, provisioning database service is free, and when you share your databases with other customers, that also we don't charge extra. So there is no charge for actually sharing the data, but both the parties should have Azure Data Explorer cluster in the same region. So the experience is you will have to provision Azure Data Share, and this is a service which helps you to share your data across different products. So if you are sharing data from blob storage or ADLS or data lake or something, you have one single place to go look at all the data that you're sharing with other parties. So you would go and start a data share and create a new data share. I've already created it, so you'll select in-place sharing, give some name, and fill your terms and condition and so on. And the next is the data set. This is where you would select Azure Data Explorer and select the cluster that you want to share. So either you can share the whole cluster, all the databases on the cluster. So for example, if I select this, anytime I add new database, it will show up on the following cluster. For now, I just selected occupancy, so I'm selecting one database. I'm not selecting others. And then you follow through the process. Let's say you add that, go to recipient, and then you're going to send and put an email addresses that you want to send to. The receiving party will get an email with an invitation and all the terms and conditions. They click on the link on the email, and then it shows up as a receiving share on their end. And there they need to go and map that data and map that share to the existing Azure Data Explorer cluster. So in this place, I've already shared that to my receiving cluster, that is Ignite Demo Consumer. So in short, I have two clusters. One is Ignite Source, which has occupancy database, and I shared that with another cluster, and this could be in the same tenant as well as other tenants. In this case, it's the same tenant. And the database will just show up as a follower cluster here. It has a different icon, but it's exactly identical as this one. Now, the main advantage here is you don't have to maintain any pipelines. You don't have to manage anything. Once this symbolic link is established, whatever changes you do on the source database, it's going to show up on the follower database in near real time. So for example, this particular table is receiving data every 30 seconds. It's about 20,000 rows. So if I go to the other database and see how many data do I have, so it's an exact same count. Now let's see the last events that came in. So in this case, within 30 seconds, it has already synced. So both the databases are already synced. If you keep running couple of times, you would see like half a second or second latency, not more than that. So depending on the data volume and so on, you can see within few seconds to few minutes latency. But absolutely there is no management required. And let's say if I'm here and I go and add a new table, I created a new table. Now in a traditional world, if you create a new data set, new table, you have to work with the other party to create the pipeline. They have to change their ETL process. They have to go read it. They have to redesign their database and so on. Here there is nothing like that. So my database is showing here. I just need to go here and refresh. And then the database shows up here. The table will show up here in few seconds. Yep, new table. So it just shows up in few seconds there. And with the same schema, and as I update the source table, this will start populating. So that's what we wanted to show you today. This enables a lot of different scenarios that Uri mentioned. You can collaborate more efficiently with your teams and external partners and customers in a very different way. Thank you.
Thank you, Manoj. So, few things. This is another announcement that we've made, and Azure Data Explorer is already one of the most competitive services in terms of price performance. And what we're announcing, beyond the compute reserved instances that we announced during the summer, which means that you can buy reserved compute instances and reuse it for other workloads, and then Azure Data Explorer consumes from that. We're also announcing discount and be able to consume the premium storage reserved instances and Azure Data Explorer specific reserved instances with 30% discount over 3 years and Azure storage discount. That actually creates a deep discount, so you can reach almost like 50% discount over the entire Azure Data Explorer over 3 years, which is an incredible value for investment. Check us out. If you see that we're not price competitive, definitely talk to me, reach out to me and talk to me. I believe we are by far the most efficient service in this domain. The last thing that I want to mention is that we keep shipping features on an ongoing basis, the ability to manually enable availability zones, encryption and rest, turning it on and on from the portal, the ability to use our smart autoscale from the portal to activate it, switch between the autoscale mechanism, to turn on and off streaming ingestion, and soon the ability to turn on and off the Python and R support without the need to go through the ticketing system. And the last thing, which also is highly related to the two examples. We added geospatial capabilities, geospatial operators and types that makes it far easier to build geospatial aware applications. And we are moving very, very quickly, and this is a fascinating journey. So thank you so much. These are the sessions that we've had. The booth is already closed, but I've met quite a lot of you already there. There are a lot of links over here, including the cost estimator that is very useful in order to estimate the financial feasibility of a deployment for your workload. And thank you very much for making the time.